Hello everyone. In this example, we will see how we can solve truss having thermal changes and fabrication errors. So here in this example, we want to calculate the force, okay, member 1 and 2 of been connected. And also we have in member number 2 was made 0.01 meter too short, okay, before it was filled into place. So this word, if we see in the example, short or reduce, it's mean minus, so that the delta L equal the changing of length equal minus 0.01 m. And if we see long or increase, that means it's positive. Okay. Another one or another part of solution, we should give global system for X and Y of structure, like here, as you see. I already given the number of joint. This is 1, 2, 3 and 4, and for global system we have, this is number 1, this is number 2, 3, and this is 4, 5, 6 and 7, 8, and also the direction, as I said in previous video we have the direction to know which is the far and which is the near point. For example, here, member number 3, we have this is the N node and this is the far node. And for number 2, this is the N node and this is the far. And for member number 1, this is the near point and this is the far point. So now, after that, we can solve the lambda, or we can find lambda X and lambda Y for each member. Lambda X equal X far minus Xn over L, and lambda Y equal Y far minus Yn over L, okay, for each member. So actually you can do by yourself how we can find the lambda X and lambda Y for member 1 and 2 and also member 3. Here actually I focus on member number 2 because we have the changing length in member number 2, as in the example say, and it's short, so it's the changing L or delta L equal minus, okay, 0.01 m. Now after that we should find the force, okay, and let me to see here this is member number 2, okay, this is member number 2 and the direction is like this. This is the near point and this is the far point. This is the global 2, global 1, and this is I think, yeah, 5 and 6, 5 and 6, okay. So that to calculate the force, we have force number 1, 2 and 5 and 6. This is force for nx and force for ny. The F5 force for x and the force number 6 for force for F, or force for far node on Y global system. This is the equation. I will follow equation number 9 because the question is given to us changing in length. So the form of equation number 9 is look like this. This is the equation. Okay. AE is already given in our example is 8,000, and the changing of length is minus 0.01, and the L is the length of member. Okay, and lambda x we already find it, and lambda y, and the second part of matrix just put it the minus here. Okay, so it's just substitute our values here. This is the lambda x, lambda y, minus lambda x and minus lambda y, and the length of member, it's the incline members. Sorry, I didn't give the dimension. This is 3 meter, and this is the length is 4 meter. So the length of member number 2 is 5. Okay. After just solve this matrix, you will find the values of force. Okay. Now in the next step, just how can I say, it's collect the K, because we have 3 members here in this example. So we have K1 plus K2 plus K3. This is the K matrix. This is force matrix, and this is the displacement matrix. Okay, just collect and summation all values, and this is K11, K12, K21 and K22. Because we have 2 known forces, and we need how we can define how we can find the D1 and D2, because it's unknown values. You can go to previous video to see how we can collect and how we can do multiply all matrix. So and plus the F node, let's call this matrix is F node. Okay, it's come from the previous slide. This is the value of forces that apply, so that's effect by thermal, and put these values depends on the number of global system. We have just 1, 2, and 5 and 6. Okay. Calculate this matrix, and just make a sample. Take to define is actually divided matrix for 2 parts to make it easy, like this, and find D1 and D2. After you calculate, this is the value of D1 and this is the value of D2. Next step is how we can find the internal force for each member. It's same way as I explained in previous video. You can go and see. Here actually let me to try to make it for you the number 1 and 2. So number 1 we don't have any changing, or let me to, this is force number 1 equal AE over 3 the length of member, sorry, let me to rewrite again. Force 1 equal AE over 3. Lambda x for member 1 is 0. Lambda y for member number 1 minus 1. Minus lambda x is 0. And minus lambda y for member number 1 is 1. And then the displacement D3, D4, D1 and D2. It's depend on the near and far nodes. Okay, so D3 we don't have is 0, D4 is 0, D1 is already find minus 0.003704, and D2 already we find it minus 0.002084. Okay, plus F for F small naught. Okay, so this is for thermal. We don't have thermal in member 1, so F naught it will be 0. Okay, just multiply this matrix by this matrix and find the F1. So the F1 it will be equal minus 5.56 kilonewton, and this is compression because it's minus. For member number 2, first of all we should find the F naught. Okay, or you can say it's like F2 naught for that's mean the for member number 2 equal minus delta L AE over 5 the length. AE is already given 8,000, and delta L is minus 0.01, so this one is equal 16. Okay, then find the F2 equal AE over 5 the length, lambda x 0.8, lambda y 0.6, minus lambda x minus 0.8, minus lambda y 0.6, and the displacement is we have for member number 2 D1, D2, D5 and D6. You can go to the first slide to see the direction and which one is the near point and which is the far point. So the D1 already we find in the previous slides, and also D2. D5 and D6 I I think it will be 0. Oh, sorry, we have these, we have values of D5 and D6. Oh, sorry, it's 0. I'm very sorry, it's 0 from, we can get from this one. It's 0, 0. This is this values just for thermal. Okay, so don't confuse. Okay, plus 16. This is the F2 node. Okay, and calculate it. You will find 9.26 kilonewton. This is tension. So try for member number 3. Number 3 is look like the member number 1. No need to take many times to find the F3 node. In member number 3 is 0. Okay, so thank you for watching and listening.